Okay, well, good morning, 8th grade. We are on a new lesson today. This is lesson 10.5, and it is on what is called the counting principle. Okay, the counting principle. Not principle as in Mr. Wrench, but the theory of counting things. That doesn't sound too bad, right? We all like to count. Counting is fun. So basically, it's this idea right here that we have what's called a tree diagram. Okay, tree diagram. And what happens in a tree diagram is, let's say that I flip a coin 3 times. Okay, now we're going to show what this would look like. So if you need to write this down, we're going to make a tree diagram if I flip a coin 3 times. Now, let's say the first time that I flip it, okay, this is number one, I can either get tails or heads. How many options is that? Just 2 options. But now the second time, I can get tails or heads again. Okay, so this is the second time I flip it. And if I got heads the first time, I can still get tails or heads the second time. Then I flip it one more time, and look at this. I could get tails, 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 heads. Look, it's still the same thing. Over and over. So, the amazing part is to count up. The first time, I only had 2 options, right? I had 2 choices. But then by the second time, look how many I had. 1, 2, 3. There were 4 options. Then by the next time, the third time, this is what's amazing. I had 1, 2, 3, 4, 5, 6, 7, 8 times. What's going on? It's going up by 2 or times 2 each time, right? 2 times 2 is 4. 4 times 2 is 8. Okay, so let me draw a little. I'm going to draw that diagram again, right? So the first time we could have tails or heads, and then we get tails, heads, tails, heads, and then for each one of those, tails, heads, tails, heads. It's actually really hard to draw and not run out of space because it's so many options. Okay, so that's 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Now, the way I could have figured this out is that I could have just made this chart and done this, okay? So some of your homework, you're just going to use a chart that is like that to figure out what you're doing. Okay, so there's 3 times, you're doing it 3 times, and then you're doing 2 times each, so it's just 2 times 2 times 2. It's actually 2 times 2 times 2. So you could have done that, right? You said each choice has 2 options. There are 3 of them, so it's just 8 total. So that's how we do that when you use a tree diagram. Okay, so your book has other examples on page 420 if you need to look at other examples. Okay, page 420 has some more examples. So it's very easy to make this diagram. I'm going to do it one more time. So let's say that we could choose between, we're choosing shoes, and we could choose red shoes, blue, or white. And then we could choose that they were glow in the, let's see, let's use flashing, like shoes that had the light up, if you guys remember flashing, or non-flashing. Okay, I think the flashing shoes have gone out of style, but let's say we had that. I'm going to label this R. You could choose red first, blue first, or white first. And then from any of those choices, you could choose flashing or not flashing. Flashing or not flashing. Flashing or not flashing, okay? So how many choices did we have? 1, 2, 3, 4, 5, 6. Now, you see how I could have solved this, though? I could have said these 3 are in a group. So that's a capital or a big 3. These are only 2, and these are 3. So it's just 3 times 2, which is also 6. Do you see that? Isn't that amazing? There's 6, and there's 6. So the total is 6, and I can find it either way, okay? I can either do it with the diagram by listing them out and then listing them all out here, and I count up the ones at the end only, or I could just multiply, do 3 times 2. So this leads us to the fundamental fundamental counting principle, which is this right here. If there are if it's basically this, if there are p ways, that's just a variable, p ways to do something, and q ways to do it again, that all equals p times q. That's what I did. If you go back to this video and go back a little bit, you'll see that, right? It was the first one, p, times the second one, which was q. Okay, so let's use this example. If you need to pause the video, go ahead. But this is going to be our example. So let's say that we have, this guy has, this lady has 5 dresses. 5 dresses, that's fun. And 4 shoes. Okay? 5 different dresses and 4 different shoes. The question is, how many different combinations could they have? Okay, this is very easy. All we do is we take this 5 times this 4, and that is 20. There are 20 ways that person could wear their dresses and their shoes, right? For you ladies, you would have 20 different options that you could come up with. So that's very easy, right? You guys can do this. I believe in you. You're very smart. You can solve this, okay? Now I'm going to insert this picture. This is on page 421, this exact example. Okay, so if you see it, it says example 4. So what happens if they give you something that looks like this, and they say you get to choose? You gotta get to choose an exterior, you get to choose an interior, you get to choose an entertainment package, and then, so this is like for choosing a truck, and then you get to choose automatic. Okay, you can see right here, all that I want you to think of this is as a bin. This is bin 1, bin 2, bin 3, and bin 4. And all we do is we have to multiply them together, however many are in each one. So how many are in bin 1? This one right here, there are 4. Do you see that? 1, 2, 3, 4. So I write 4 times. How many are in bin 2? This bin right here, 1, 2, 3. See that 3? So 4 times 3. Now, so how many are in this bin right here? 1, 2, 3 again. So that's times 3. Times 3. How many are in the last one? 1, 2. So it's times 2 times 2. And you see what they got here when they multiplied that together. You can do it on your calculator. You get 72. So if you do that, you're always gonna get the right answer. You just get how many are in each one. 4 times 3 times 3 times 2. Now imagine, okay, I want you to look at the example here that they have. I'm going to clear this and re-put the picture in. So the example that they have on 421 is that sometimes they say that you already selected one. Let's say that you chose that you decided to go with white. Okay, but then you still get to choose all of these. Now do you see that it's going to be 1, okay, because you're down to 1 option. Now times these 3. Now times these 3. Now times the last 2. And that right there is only 18. Do you see that? That's this example right here. If you got confused, you need to follow along. Okay, so if you think of it as bins, this is bin, this is a bin, and that is a bin. Okay, and in this case, since we had already chosen white to begin with, we only had 1, which didn't affect the total number of choices. Okay, so this is I'm going to write one more example down, and we'll be done and tell you what the homework is. So this is the principle. If you have 3, wow, it's a bad 3. I'm sorry. 3 blouses for you ladies, 3 blouses, 2 skirts, and 4 pairs of shoes. That leads to this: 3 times 2 times 4, which is 24 outfits, right? So that's the principle right there. You just do the bin times the bin, and you get the total, okay? So here is the homework. It is on page 422, and it is 1 through 39 odd, okay? 1 through 39 odd. Okay, so not very hard. I'm doing exactly what we just talked about. So make sure that you draw the diagram if you need to. I don't care for a lot of them. I just wanted you to get the right answer. If you use the diagram or the other way, I'm good with whatever you want to use. Okay, Mr. H, over and out.